Good morning, students. In continuation with the previous topic, we will start with disaccharides. So in the previous class, we have started with monosaccharide, its properties, optical activity, everything we have studied. So we'll start now with disaccharides. So disaccharides are the sugars which has two monosaccharide, which will be linked with glycosidic bond. And this disaccharide will be composed of any two simple sugars. It can be any two monosaccharides, and this will be linked with the help of covalent bond. So disaccharides are crystalline water-soluble compounds. This will also be soluble in water. Example, we have normal table sugar, which is your sucrose. So that is also a disaccharide. So this monosaccharide, which will be linked with glycosidic bond. So two monosaccharides will be linked with glycosidic bond. So usually in the position of alpha 1,4 or alpha 1,6 or beta 1,4 or beta 1,6 linkage. So these linkages only will be used to make disaccharides. So this glycosidic bond can be cleaved only by means of glycosidase enzyme. So different glycosidase enzymes which will cleave this glycosidic bond to yield the respective monosaccharide. So there are three major classes of disaccharides which fall into the category of oligosaccharide. So basically the simple classification of carbohydrate follows as your monosaccharide, oligosaccharide, and polysaccharide. So under the category of oligosaccharide, we have disaccharides. So there are three major disaccharides which include sucrose, lactose, and maltose. So first we will start with sucrose. Sucrose, of course, we all know it is synthesized from the green plant using photosynthesis, which consists of a molecule of glucose as well as fructose. So two monosaccharides should be there in case of disaccharides. So one is glucose, the other one is fructose. And of course, this would also be linked with alpha 1,4 linkage with beta linkage also. So this you have to remember. Sucrose is composed of glucose and fructose. The second one is lactose. Lactose, of course, whatever the carbohydrate which is present in the milk, you call it as milk sugar. And this is found in almost all the mammalian milks and consists of glucose and galactose. And of course, this is also connected by means of beta linkage. So sucrose is a normal table sugar, whatever we eat, and lactose is a sugar which is present in the milk. And lactose is made up of glucose and galactose. So these are the two monosaccharides which are present in lactose. The third one is maltose, and maltose is produced from the breaking of starch, especially the partial digestion. And this consists of two molecules of glucose. And of course, this is also connected by means of alpha linkage. So two glucose molecule will yield maltose. So sucrose has glucose and fructose, lactose has glucose and galactose, whereas maltose has two glucose molecules. And other important disaccharides, which includes terhalose, and this also will be present in single-celled organism, and in many insects you can able to see this kind of terhalose, which also has two molecules of glucose, but the linkage will be again an alpha linkage. But this linkage is distinct from whatever you could able to see in the maltose. So maltose also it is alpha linkage only, but here the linkage is entirely different in case of terhalose, since this also contains two molecules of glucose. Let's just see the general structure of your sucrose. So this will be your glucose unit, and this will be your fructose unit, and this bond you call it as glycosidic bond. And in case of your maltose, you have one glucose, the other one is also glucose, which is linked with glycosidic linkage. Again, this will be the general structure of your maltose. And for the lactose, you have galactose structure along with glucose. Again, you have glycosidic linkage. So this will be the general structure of your lactose. So we'll see where you will be able to identify this, what kind of sugar it is, all these things we'll see one by one. So if we take the structure of maltose, already we discussed maltose is having two glucose as its monosaccharide. Of course, it's a disaccharide, so two monosaccharide, which will be glucose plus glucose. And here C1 of glucose will be linked to C4 of another glucose molecule to form a glycosidic linkage. So C1 will be linked with C4, carbon 1 with carbon 4 to form a glycosidic linkage. And this is covalent linkage. And it is a reducing sugar because one C1 of the second glucose solution is having free aldehyde group. So already we have seen in the first class, reducing sugar in the sense it is capable of reducing the copper to cupric ion. So from blue color to brick red color. So if it could able to reduce it, then you call it as reducing sugar. So this maltose on hydrolysis will give you 2 units of glucose, because already we have studied it is made up of 2 glucose units. Then structure of lactose. Lactose is milk sugar, or just now we saw it is present in the milk. And lactose is formed by the combination of glucose and galactose. So beta glucose and beta galactose will be the two combination of glucose, two combination of monosaccharides. And of course, this is also a reducing sugar, because this also is capable of reducing copper to cupric ions. And lactose on hydrolysis will give you glucose and galactose, because we saw the two monosaccharide which is present in your lactose is glucose and galactose. So you will be getting glucose and galactose upon hydrolysis. So this trisaccharide we will see in the next class. Thank you, students.